Okay, I just want to talk about the formula for the area of a sector, and first of all in radians, and I just want to show you where it comes from. So the area of the sector, if theta was in degrees, the area would be theta on 360 times pi r squared. But if theta is in radians, that one's in degrees, but if theta is in radians, then it's theta out of 2 pi. That's what fraction of the whole circle we have here, times pi times r squared. So the pi's go out, so you get theta r squared on 2, which is where you get your half r squared theta. Okay, so find the area of these. So this is a half r squared theta. We're going to do this in radians using the radians formula. 3 squared times 40 pi on 180. So if it stands alone, it radiates. So if it hasn't got a sine, cos or tan attached to it, put it in radians. So it's a half times 9 times, that will simplify to 2 pi on 9. 9s will cancel, 2 will cancel. So the area is actually pi centimetres squared. Okay, this one here, it's a half r squared theta. So it's a half times 4 squared times pi on 3. A half of 16 is 8, so it's 8 pi on 3 centimetres squared. Alright, the arc length of a sector is 4 pi centimetres. We want to find the area, and the radius is 6. Okay, so r theta equals 4 pi, so 6 theta is 4 pi. So theta is 4 pi on 6, or 2 pi on 3. That's 120 degrees. So the area is a half r squared theta, so it's a half times r is 6 times theta, which is 2 pi on 3 from here. So a half of 6 squared, so it's a half times 36 times 2 pi on 3. A half of 36 is 18. 3 goes into 18, 6. 6 times 2 is 12, so it's 12 pi centimetres squared. Okay, this one here, the arc length is 6 and the area is 12 of a sector. So that means r theta equals 6 and a half r squared theta equals 12. So I just have to solve these simultaneously. So that means that if you look at this, theta is 6 on r. So that means that if you put that into this one, that's a half r squared times 6 on r equals 12. The r's will cancel. A half of 6 is 3, so 3r equals 12, so r equals 4. And then r theta equals 6, so 4 theta equals 6, so theta is 6 on 4. So you just got to sub it back into one of them. So theta equals 1.5 radians. Okay. There is another way of just solving these two equations, and that's like if you go 1 and 2, if you put equation 2 on equation 1, you get a half r squared theta equals 12 over r theta equals 6, and they cancel out really quickly. The thetas go out, the r's go out, and you get a half r equals 12 over 6 is 2. So r is 2 divided by a half, or times 2, which is 4 centimetres, and then etc. You can go on and find that theta. But if you do it as a fraction, sometimes that's easier if you remember to do that. Okay, if we want to get this shaded area here, the area is the big one sector minus the small sector. So it's a half r squared, I'll put a big R, theta, minus a half little r squared theta. So big R is 4 plus 2, which is 6. So 6 squared times pi on 5, minus a half times the small radius is 4. 4 squared times theta, which is pi on pi. Okay, so I'm going to take out the half times pi on 5, because that's quite common. I can put this into my calculator, but it'll just help me simplify this without a calculator. So a half times pi on 5 is pi on 10. That's 36 minus 16. Pi on 10, 36 minus 16 is 20. So this is going to actually be 2 pi, that area. So it's 2 pi centimetres squared, because 10 goes into 20 twice, and 2 times pi is 2 pi.